Welcome to helpyourmath.com. In today's problem, we're going to be dealing with f of g of x's, the domains of f of x, domain of g of x, then the composition function of f of g of x and g of f of x, and their corresponding domains. So we'll be finding the domain of f of g of x and the domain of g of f of x and their restrictions. This is a pretty difficult problem. At first glance, it does look kind of easy, but there are some restrictions we're going to pay close attention to, all right? So let's begin with this. We have f of x is equal to 1 over x minus 5, and g of x is the square root of x. The domain of the f of x function, and for this problem, since we have a rational expression, we know that the denominator can never be equivalent to 0. So we look at our condition for 1 over x minus 5, knowing the only condition is the exception of when the denominator is 0. So we set x minus 5 not equal to 0, add over the 5, and we have our domain exception. X cannot equal positive 5. So our domain for the f function is going to be x belongs to all values from negative infinity to positive 5, union 5 to infinity. Moving on, we're going to do the domain of the g function. And now doing the domain of the g function, we see the g function is equivalent to the square root of x, where in every case for square roots we have to remember the square root cannot be taken if the number is less than 0. So the x value must be greater or equal to 0. And this pertains to all inner functions of square roots. You just have to set the inside greater or equal to 0, except for the case when you have it in the denominator, when it can only be greater than 0 because it will be at the bottom of the fraction and the fraction itself cannot have a 0 in the denominator. So here we see our domain exceptions are everything below 0, and we'll say the domain of the g function is x belongs to, beginning with 0 inclusively, all the way to infinity. Now let's put our first composition function together, the f of g of x, in which we have the function of g of x as an input into this function. And what we're doing here is we're swapping whatever the g of x function is as the input for this system. So we have basically 1 over the g of x, take away 5. And of course, for this function to work, we have the g of x minus 5 cannot be equivalent 0. Right? And this I'm just going to leave as a stencil while I work out the actual problem using the input of the system. I'm using this so I can mark all the work that is necessary to complete this. Now, we have to remember one thing also while we're doing this, but let's get to the work first. Here we have the function of the input as g, which g of x is the square root of x. And this then becomes 1 over the square root of x minus 5. And we can see it looks identical, where the input is the transposition of the values, right? Where the g of x is the radical of x. And finally, we know the condition for this to work is the square root of x minus 5 cannot be equal to 0. Now, let's get into part D, because this doesn't represent the actual domain. This is just the reference value for what inputs would not be accepted. But let's compare this to what the domain of inputs are for the actual domain of f of g of x. And now when we're putting this together, we have the function of it already right here. And we know this is just 1 over radical x minus 5. This represents f of g of x. But let's talk about the domain of this function. And the domain of the function of g of x is actually a weird restriction, because here we know for g of x to represent a real number, we have to have the condition of g of x as part of the domain for the f of g of x, because g is restricted to all values from 0 to infinity. However, the denominator here is restricted to not having one value. That makes this true, because it's also a rational expression. So we're going to have two conditions going together to form the domain of f of g of x. So let's take a look at those rules, because here we have the domain case where the input of this system fails, but we also have the domain of g of x being all real numbers greater than 0. And here we have that one exception. So we're going to solve that one exception, which is radical x minus 5 cannot equal 0. We're going to add 5 over. where these 5's go away, we have square root of x is equivalent to 5. And then we're going to square both sides where this cannot equal to 5, right? So we have x cannot equal 25. So here's our one exception to the domain of the g of x as an input, and we combine them two together, right? So now we have all real values from 0 to 25 excluded, so we have a hole here, and from 25 to infinity. All these values will work in the f of g of x, and this makes the system for the domain work. So we take the condition that the function produces, as well as the condition of the inner function functioning as a whole real number, right? Not a whole real number, any real number, right? Imaginary numbers must be excluded. Anything below 0 for g of x will produce an imaginary number. So moving on to part E, we're now looking for the g of f of x, right? And now when we're looking for the g of f of x, this is going to work quite the contrary, right? Instead of inserting the g into the f, we're going to insert the f into the g. And so this here gives us the g of f, the g of the f of x, which is going to produce the square root of the f of x. And in this case, we know for this to function, the f of x must be greater or equal to 0. And now let's resolve what this actually is, because we know that the g is taken in an input that is the f of x function, which is 1 over x minus 5. And here we get the square root of 1 over x minus 5, where again 1 over x minus 5 must be greater or equal to 0. And now we'll begin finding the domain of this function, right? So we're just going to try to work up here a little bit for this. And we have here the f for the domain of the g of f of x. First, we're going to resolve a little bit of the kinks, as we said before. The domain for the f of x, which is the input, has all real values except for 5. Right? So our domain is a pretty big space, but the condition for this to function is the inside has to be greater or equal to 0. And since we have the exception of 5, we're going to apply that exception to this rule, and we're going to solve what the domain is here. And solving here the domain, we see this is always going to be greater so long as this value of x is a positive value. Right? So the only case we're going to have for this being negative is all values that make this denominator negative. Right? So we're going to take the x minus 5 and we're going to set it greater than 0 to get the domain of what this input system can take. And also remember that x minus 5 cannot equal 0. And here we add 5. This is the easier domain restriction to solve. And we get x cannot equal positive 5. Here's one domain issue. And then we have to also remember the denominator must only produce positive numbers to get the domain, because otherwise this would be less than 0, right? Because it'll be a fraction that is less than 0. Every positive number will be greater or equal to 0. So here we add the 5. And lucky for us, this produces a domain exception saying the values must be greater than 5, right? And this says it can't be 5, so far we have a great exception. We also know the domain for this, and the domain for the a, which is it just cannot equal 5, remains the same. So we have our domain for the domain of g of f of x based on just this part of the solution, since this happened to work correlatively to this. So our domain is just x belongs to 5 to infinity. Thank you.